All right, welcome everybody. This is going to be a little review video to just go over all the stuff in your Cami, make sure that you understood everything that you wrote down and completed. It's also going to be a way that we can check, make sure you did all of your work, and then a way to help you prepare for your Section 3 quiz, because you will be taking that on your own while you are at home and not in class when you are with us. And we're going to miss out on some of that class time to be able to review some stuff with you. So make sure you have your phone away, right? If you need to, press pause, put your phone in a different room, make sure it's not a distraction. It is important that you pay attention to this video. You should have two things out with you. So after I go through this, you can hit pause, make sure you go get them. First thing you're going to need is your Section 3 Cami packet that we gave you. It's a white packet, right? The front should look just like it does here. And I'm going to be starting at the part that says checking up. Okay, so it says checking up, page 37, right at the top. That's where I'm going to be getting started eventually. Another thing that we're going to get to at some point, but not immediately, will be your green sheet Chem to Go section. So you'll want to turn to the page that looks like this, and we're going to be going over what you did on either Friday or Monday, depending on what group you are in. All right, so up to this point, you should have already watched the notes for the green sheet and have all those filled in. You should have already completed the green Chem to Go, even though we haven't reviewed it. You should have, even before that, you should have completed this what do you see section, right? What do you think section. Your before Chem words should be done, right? And before watching this video, you should have completed your after Chem words, right? After reading your Chem Talk. And this is where you should be. So the first open spot you should have should be in the checking up section. All right, so pause the video if you need to. Make sure you have all the materials you need, and I'm going to get started. So checking up, number one says, right, and we are writing these answers in complete sentences. You can see that here in bold and italics. When we grade this, we are going to be looking for complete sentences. Right, so make sure you're using periods and capital letters. All right, number one, if somebody handed you a substance in a jar and asked you if it was a solution, a colloid, or a suspension, how could you tell and what would you do? All right, so we identified some of them in our investigate. We had 6 test tubes available for each lab group, some containing solutions, some containing colloids, and some containing suspensions. All right, so we got to think, what do we do in that process to help identify them? All right, so I'm going to be filling this out on Cami with you, but you should be writing this in your Cami packet. All right, and a really nice way to do this would be for you to complete this yourself and then check your work with me. All right, so if somebody handed you a substance in a jar and asked you if it was a solution, colloid, or suspension, how could you tell and what would you do? The first thing you want to do is you want to look at it. So look at the mixture to identify the size of the particles. All right, so we're looking at the size of the particles inside of our substance, right? Are they large particles that we can see with our naked eye? If they are, right, so large particles, we would say that looks heterogeneous, and that would make this a suspension. All right, so if we can see different pieces of this mixture with our naked eye, we know automatically this is a heterogeneous mixture. Right. I might spell that wrong a couple times this video, and that's okay. This is not a spelling test. All right. Now, if we're looking and we don't see any particles, so can't see particles, with your naked eye, that tells me I either have a solution or a colloid. It does not narrow it down for me. I'll need to do something else. So one thing we could do is we could use a microscope to look at both the solution, or to look at the mixture to tell whether it was a solution or a colloid. If you can see particles with a microscope, then you have a colloid. Right? But we don't always have a microscope right, available to us. So one thing we can do is we can use light, shine a light through the mixture. If we can see the light, then we know we have a colloid. Right? So we'll perform we'll use a laser pointer or just a form of light, and if the Tyndall effect does appear, which we will talk about a little bit more in number 2, we have a colloid. Alrighty. So there are other possible answers you had. If you had an answer that included filtrating the mixture, and if when passing that mixture through a filter, it was able to separate, you know you have a suspension, that would be good. But if we're going to narrow down the difference between a solution and a colloid, you're going to either need some strong source of light like a laser pointer or a microscope to look at the size of the particles. All right, so number 2. All right, number 2 says, what does the Tyndall effect look like? Why does it occur sometimes but not other times? All right, so you should remember back from your lab that when we shine the laser pointer through a colloid, or the Tyndall effect, it looked like a solid strip of light passing through the substance. Or I'm going to write mixture. All right, so we could see that line go the whole way across. Right? It kind of makes you think, when you watch spy movies and you see those lasers, right, is that always realistic? Should they be able to see those laser pointers as they're just passing through the air? Or maybe you want to keep an eye out and see, are they spraying something into the air to create a colloid around them so that they can see the lasers? And we're going to take a look at some pictures as well. So what causes this? So what causes the light to appear? So we have the scattering of the light bouncing off of, scattering light bouncing off of the small particles in the colloid. I'm sorry if it sounds weird if you're listening to me while I'm also typing. It's hard to do both at the same time. So we see the Tyndall effect in colloids because, right, the particles are small enough, right, to not block the laser pointer like a suspension, but they're large enough that they will interact with that light, right? The light will bounce off of them. In a solution, the particles are so super small that the light's just passing right by them, right? There's not enough there for it to block or to bounce off of. And with the suspension, right, they get blocked by a large piece and the stream of light is just stopped completely. Alrighty, so you should have your checking up questions done right here. Our essential question says, what would you see if a laser pointer was shown through a solution and a colloid? Be sure to think about what it would look like in the beaker and what it would look like on the wall. Okay, so we have a laser pointer passing through a substance. On the left we have a true solution, and on the right we have a colloid. All right, so if I want to draw what my laser might look like, in a solution we would not see the laser pointer pass through at all because the particles in there are too small. Right? We would not see the laser pointer in the air, but we would be able to see a dot of the laser, right, on the wall. Right? Just imagine you're just pointing a laser pointer through air. Now if we have a colloid, right, we should be able to see the laser pass the whole way through. Right? It would be a much straighter line than that. Right? You would not be able to see anything in the air, but we would be able to see, right, a dot on the wall. Right, so big difference here between solutions and colloids is that colloids will show the Tyndall effect. All right, so I'm going to move on to something a little bit different, just to give you a little bit of a better example. So take a look here. So here are 5 mixtures. We have a ketchup water mixture. We have spices and oil, kind of like a display thing you might see on like a windowsill in the kitchen, or maybe like Italian dressing. We have salt water, we have milk, and Kool-Aid. All right. So if we're looking at each one of these, right, you're going to be prompted with questions in a second, and I want you to answer them using the same skills that we did or used in lab and the information that we have learn throughout this section. Alright, now we're going to be looking at the Tyndall effect and how that affects different substances. So if we have milk here, laser pointer shining through milk, right, what do we see? What about with salt water? Kool-Aid and ketchup water. Alright, now you might have noticed that there was one missing here, and that would have been our spices and oil. But we had eliminated that as a possibility of a solution or colloid back in the beginning when we declared it as a suspension. Alrighty. Alright, so now we're going to turn our focus towards the what do you think now? So this is the question at the very end of your CAMI journal. Alright, so it says, imagine if you were given a jar that contained a mixture of salt, sand, and iron fillings. Right, how would you separate each item? So we have these all mixed together, right? Some sand, some black pieces of iron, and some normal, typical table salt. Right? How can we get them apart? Right, and there are some hints here. It says, would they pass through the filter paper? Would they dissolve in water? And would they be attracted to a magnet? So you're going to write a step-by-step procedure explaining how you're going to do it. But you and I are going to brainstorm right now before you write anything down. Alrighty, so I think I actually have the wrong thing up. Here we go. Alright, so first thing I want us to focus on, right, is what is magnetic? Right? Is salt magnetic? Or sand? Or iron? Which one of those will be attracted to a magnet, right? And would we be able to extract that from the mixture without taking anything with it, right? Our next hint, right, talked about dissolving in water. Right, so let's say, right, you may or may not have already removed an item and you only have 2 remaining, or maybe you have all 3 remaining at this point in your plan. So we pour that mixture into a beaker of water and we stir it up really well. All right, so would any of the substances dissolve? Would salt dissolve? Would sand dissolve? Right? If you still have iron in your mixture, would the iron dissolve? All right, and then you want to think, right? You might have now already removed one substance, and it looks like one of them is gone, right? But we know it's still present in the liquid around us. So if we pass this through filter paper, right, just like we did in our lab, right, what would pass through? Right, so I'm assuming at this point, right, if you haven't guessed so already, you probably removed the iron with the magnet, right? And you hopefully did that initially before it became wet and clumped together. Then we just had sand and salt, and if we poured water into that, or poured that into water, the salt would have dissolved, just leaving behind a mixture, right, of sand and salt water. So what would happen if you poured that, right, into our filtration, just like we did in our lab? In our lab, we poured, right, that soil, or it was soil and water or sand and water, we poured that into the filter, right? Did that pass through? And we also did pour salt water. So did salt water pass through the filter? All right. Now it's going to be your job to write your own procedure. So make sure you are numbering each of your steps. You are writing in full, complete sentences, right? And this should take you a minimum of 3 or 4 steps, right? But you can have plenty more depending on how detailed you want to be. And a true scientist, right, is as detailed as possible, because you want this procedure to be able to be repeated by anybody and be able to produce the same results. All right, so this should get you prepared for your Unit 3 quiz. If you have any questions or concerns, please contact your instructor immediately, and have a good night. Good luck.